Okay, now let's start to talk about how we can fill orbitals. If you want to fill orbitals, you need to fill it from the lowest energy to the highest energy. So the usual order is filling from S and then filling to P and filling to D and then filling to F. But there are some exceptions. Some people will try to use the tree method and start writing all the orbitals and start to arranging it and to know which one is before which. But I'm going to teach you an easier method. You then start drawing the different orbitals and start arranging. So they write 1s and 2s, 2p, 3s, 3p, 3d, and then they start to put arrows so that you know that 2p is then 3s, then 3p, 4s, 3d, 4p, and 5s, and like that. But I will teach you a better method. Let's see first what are these symbols which are 1s, 2s, and 3s, and explain what it is. The 1s is actually the s orbital which is found in the first floor. So because you mentioned that you have the first shell which is the number one shell, it is in the ground floor which we have imagined is very similar to the building first floor, and we said that it contained only one type of subshell and it was called S, while the second shell contains two types of subshells. The first one was called S and P. In order to differentiate between the S of the second shell and the S of the third shell, we are going to give it numbers. So we are going to call this 1S and call this 2S. And this is a P which is found for the first time, but still it is found in the second shell, so we'll call it 2P. In the third shell, I will have three types of shells. We have the 3S, we have the 3P, and we have the 3D. So three type of subshells in the third shell. And in the fourth one, I'm gonna have four types of subshells, and we are going to call them also 4S to know that this is the S of the fourth shell, the 4D to know that this is the 4P, sorry, to know that this is the P of the fourth shell, the 4D, and the 4F. So now we have given a number for every of the subshells to know that which subshell this is for. Now let's talk about the method that I have promised you to make arrangement easier without having to draw this every time in the exam. All we have to do is divide our periodic table into different blocks. And I will tell you the names of these blocks where it is coming from now. The first block is going to be called an S block. This is the S block, and the reason the S block is called so because in all the elements that's in S group, S block, which is usually found in group 1 of the periodic table and group 2 of the periodic table, the elements in this block will always have a configuration that ends with S. So whatever element you are going to find here, either it is in period 1 or 2 or 3, 4, 5, 6, 7, the electronic configuration will always end with S1. But what is S1? We have the hydrogen atom, and the hydrogen atom has one electron inside it. So let's imagine that this guy with the one electron has come to stay here in the building. So the rule tells us that the first floor should be always filled. So you cannot go and live in the first, in the second, or in the third floor before you go to the first floor and fill it first. So you have to fill the energy levels or the shells which has lower energy before you start filling the one that has high energy. So this means that if you have only one electron to fill, you don't have any place to go but the first shell. And since it contains already one subshell only, known as S, and we have given it the name 1S because we want to make sure that we recognize it is the S of the first shell, then we will write this electron to stay here. This shell has only one subshell, and this S subshells usually contains only one orbital inside it. So in this orbital, this electron is going to reside and stay here. That's why we are going to write the configuration as follows. It is 1s, so this means it stays in the orbital, only orbital available in the s subshell in the first shell. And then 1 means that one electron only is given. So as I promised you, the H here stays in this S block, so the electronic configuration of it, this is what we call as the electronic configuration, has ended with S1. And the helium, because it has two electrons, then I will just put these two electrons here. Remember we said that this orbital, the only orbital found in S, can carry two electrons only. So this is the second electron it can carry. Because the electron wants to minimize the repulsion with the other electron, which is also negative and found in the same orbital, it will start to spin in a different direction. This means that this is the nucleus and this is the orbital. One electron will start spinning like that, so that it has a direction which is counterclockwise, while the other electron will start to spin like that, which is a clockwise direction. We do this by drawing two different arrows in two opposite ways. Now let's go back to the electronic configuration of helium. It has two electrons, and the two electrons can stay in the first shell, in the S subshell, in the only orbital there. And since they are two electrons, then we will write it as 1s2. Not only helium, but all the elements that's in group 2 are going to always end with the S2. The first number is going to change because once you go here, instead of ending with 1s, it will end with 2s or 3s or 4s, and this depends on which element. So if you are talking about lithium, the configuration of lithium is gonna end in S1 also, since it's in group 1, and all elements of this group will end with S1, but this time instead of being 1s1 for lithium, it will be 2s1. And if you took potassium, it will end in S1 also, since it's in the first group, but it's gonna end in 4s1 because it is in period number 1. So the period number is gonna tell you the number of the group, the number of the shell that this element is found in. Remember that the only element that has a configuration of S1, of 1s1, is the hydrogen, because it has no more electrons to put. So you cannot say 1s2 in it because it already has one electron here. And in the helium, you cannot say 1s1 because it already has two electrons. You already have two electrons, and you cannot put these two electrons in two different orbitals. You are forced to put it in the minimal energy orbital, which is the 1s. So you cannot go and put one of them in one shell and go and put the other in the second shell. You have to fill this up first.